I'm using this stack of nickels as my object. Here's a cubic centimeter. I look at that and say, well, it's clearly more than 1. How about 10? I'm going to guess that this is 10 cubic centimeters. Step 2 is to measure the volume of my object using a graduated cylinder and tap water. I'm putting a random amount of tap water in the cylinder. Now I have to accurately measure the water. So I'm looking at it and I'm saying I am at 62.8. 62.8. And I'm going to submerge my objects, being careful not to splash. 62.8, and it has risen to 70.0. 62.8 to 70.0. 70.0 milliliters minus 62.8 milliliters is 7.2 milliliters, which is equivalent to 7.2 cubic centimeters. So the volume accurately measured is 7.2 cubic centimeters. My swag was 10 cubic centimeters. Not great, but not terrible either. Step 3 is to get a mass. I have to have a dry object, so I use the paper towel to dry it. I will get the mass. 64.50 grams is my mass. .50 grams equals 7.2 cubic centimeters. I'm trying to now find the density, which is for 1 cubic centimeter. How many grams would that be? So that's a simple calculation. You use your calculator, you get an answer. My data calculates a density of 9.05 grams per cubic centimeter. The official density on the periodic table is 8.90 grams per cubic centimeter. So I'm off. I have some error. I can subtract, find the difference. This is the difference. This is my error. However, I want to express that as a percentage error. The way I do that is to take the error, divide by the official measurement. So for me, that is 0.15 over 8.90. That I put in my calculator, get an answer for a percentage. And I have a 1.7% error. So that means I did pretty well. My methods were accurate. One of the challenges today is to use graduated cylinders effectively. This is the 100 milliliter graduated cylinder. It has 10 lines between the number 10 and the number 20. This is the 25 milliliter graduated cylinder. It has 10 lines between the number 20 and 25. Each line here is not 1 milliliter. This is the littlest graduated cylinder you have. It has 10 lines between 8 and 10. So make sure you understand the scale of each cylinder. In this cylinder I have what looks like 12 milliliters. When I pour it into the more accurate small cylinder, I'll be able to get a better reading. The problem is with the big cylinder, anything between 12 and 13, I'm just guessing. On this small cylinder now, I can get an accurate reading. Here I can see that in reality what I thought was 12 milliliters is very close to 11.5. Having the extra lines gives me an extra degree of precision.